Let us now understand the reference chart, which will give us the number of odd days for a given period of months without having to do the individual calculation for each of the months. Let's look at what the reference chart here is and what are the different columns here. So as you can see, the first column of this chart shows the months of the year, right, from January to December. Alright, and we have a star mark here for the month of February, which means that we need to be a little careful when it comes to that month. And the reason here is that February will have different number of days based on an ordinary year or a leap year, right? If it is an ordinary year, the month of Feb has got only 28 days, so 0 odd days. But if it is a leap year, Feb will have 29 days, that means there will be 1 odd day. So we have to be a little careful if the given year is a leap year, right? The second column here shows the number of days in each of these months, right, for an ordinary year. We have to consider here an ordinary year. So if you look at it, in the month of January there are 31 days. In the month of Feb, 28 days. 28 because, as I said, we have considered an ordinary year here. If it is a leap year, it should be 29, and that is the reason that we have a star mark, which means we need to be little careful for that particular month. Then March again has 31 days, so on up to December we have got 31 days. So the second column indicates the number of days in each of these months. Look at the third column. The third column shows the number of odd days in each of these months. For example, in the month of Jan, we have total 31 days. 31 days can be split as 4 complete weeks plus 3 days. Hence we can say January has got 3 odd days. Likewise, the next month Feb, since it is an ordinary year, 28 days, and 28 days is exactly equal to 4 weeks. 4 weeks means 0 odd days, right? We have no extra number of days here. Then comes the month of March. March has got total 31 days, meaning 4 weeks plus 3 days, so 3 odd days. Likewise for April there are total 30 days. 30 days can be again split as 4 weeks plus 2 days, so that 2 extra days gives us the number of days for April, and so on up to December. The calculation is shown here. So number of odd days is what is given in column number 3 for each of the months. Now if you remember in the previous question where we had found the day of the week for 15th August 1947, we have considered all these values, right, for January 3, for Feb 0, for March 3, April 2, and so on. But now with this fourth column here, we will be able to avoid that individual calculation. The value in this fourth column tells us the number of odd days for all the previous months. So this way we can save some time by avoiding the calculation for the individual months. Let's understand what the calculation here is. Now as I said, the fourth column actually is the cumulative number of odd days for all the previous months. For example, if you look at January, we will not have anything. January, it's not applicable, because if we calculate the day of the week for a given date in Jan, right, we directly take the number of days. Let's say we have to find out the day of the week for 14th January 1967. So up to 1966 we'll calculate the number of odd days. Then when it comes to the 1967th year, since the first month is taken here, we'll directly say 14 days, because 14th January is what needs to be calculated. So for Jan, there is no cumulative number of odd days. But from February onwards, we'll have some number which will show us the cumulative number of odd days. That is nothing but the total number of odd days for all the previous months. So let's see. In the month of Feb, we have to take it as 3. So simple point here is, if you are trying to find out the day of a week for any date in Feb for all the previous months, the total number of odd days will be 3. Now before Feb we have only 1 month, which is Jan, and since Jan has got 3 odd days, we have directly got 3 here. So let's say we have to find out the day of the week for 14th Feb 1973. So up to 1972 we have to do the calculation of number of odd days, which is regular. When it comes to the 1973rd year, we have to calculate the number of days for Jan, right, directly 3. Then we'll say 14th Feb, so directly we'll take 14 for the number of days in Feb. Next comes March. For March again we have taken 3. That means if you have to calculate any day of the week for any date in March, we need to find out the number of odd days in Jan and number of odd days in Feb. Then you have to add all those values. So instead of doing that individual calculation, we can directly say it is 3 for all the previous months. What is the calculation here? 3 plus 0 will give us 3. So total number of odd days for all the months before March is 3. So let's say we have to find out 28th March 1993. Now for calculating 28 March 1993 up to 1992, calculate the number of odd days. Then you have to find out the number of odd days in Jan and Feb. Instead of doing that individual calculation, directly take 3 for March and then 28 March, so plus 28. Alright, so that's the logic, and this way we continue and find out the total number of odd days or cumulative odd days for the month. So basically the number here represents the code for the month. So based on that month, if you can remember the value, that will give us the number of odd days for all the previous months. Let us now look at the next month, April. For April we have got 6 here. So if you have to calculate the day of the week for any date in April for all the previous months, that is Jan, Feb and March, the total number of odd days is 6. So that's nothing but 3 plus 0 plus 3. The total calculation here is 6. Likewise for May, total number of odd days for all the previous months is 1. So from January to April, if you observe, what is the total number of odd days? 3 plus 0, 3, 3 plus 3, 6, 6 plus 2, 8. 8 odd days. 8 odd days is equivalent to 1 odd day. So for May we have taken 1. So the point here is, if we are calculating any date in May for all the previous months, all the 4 months, the number of odd days is 1. And then take the date of May to find out the total number of odd days. So this way the calculation continues. Now if you observe, up to May we have got 1. Then in the month of May we have got 3. So 1 plus 3 will give us 4. Then 4 plus 2 gives us 6. 6 plus 3. 6 plus 3 is 9. 9 can be taken as 1 week plus 2 days. So we have got 2. Then 2 plus 3 is 5. So 5. That means for September the code is 5. So if the date belongs to the month of September, we need to take 5 plus that date. Likewise for October, 5 plus 2, 7. 7 odd days is equal to 0 odd days. So for October we have got 0. So if you have to calculate the any date for October, what do we do? Take 0 plus that date of October. November it is 0 plus 3, 3. December it is 3 plus 2, 5. Right? So just remember this table here. For Jan we have nothing here. Then 3, 3, 6, 1, 4, 6, 2, 5, 0, 3, 5. Again, if you want to go ahead and calculate, let's understand what happens. Now next month, after December, we again get January, right? That means the cycle rotates. Now what will be the total number of cumulative odd days for January? For all its previous months, right? That's what happens. So for all the previous months, 3 plus 5. Yes or no? Up to December, we have got 5. Plus in December, we have got 3. 3 plus 5, 8. 8 is equal to 1 odd day. So we'll get 1 here. Now what does this 1 indicate? We very well know that in any ordinary year there is only 1 odd day. Yes or no? For any ordinary year there is only 1 odd day. And since we have considered an ordinary year, for all the months January to December, that means all the months before January, for whole year we have got 1 odd day. Right? So that's the point. Just remember this column here, column number 4, which is nothing but the code of the month. But be careful, if it is the month of Feb in a leap year, we'll have 29 here. Accordingly we'll get 1 here, and this becomes 4. And likewise all the other values changes. But instead of changing every other value, simply remember that if it is a leap year, we have to take plus 1 if the date is after 28 Feb. And you have to take the same value if the date is before or equal to 28 Feb. Right? Let's understand with the help of an example. We'll take the same example that we have taken earlier, 15th August 1947. Right? So let's see how is this table here, right, this last column here, helpful in finding out the number of odd days. So what do we do? 1947 up to 1600 years, 0 odd days. Then for 300 years, 1 odd day. Then comes 46 years, right? We are not considering the 47th year, right? Only up to 46 years, 1901 to 1946. So for 46 years, how many odd days? 46 years will have 1 odd day every year. But since there are 11 years, we'll have extra 11 odd days. So plus 11. Now comes the 1947th year, right? 1947th year. In 1947th year, we are referring to the month of August. We are in the month of August. What is the code for August? August, the code is 2. So directly take 2. And what is the date? 15. And since this is an ordinary year, we don't have to worry about, one additional day in the month of Feb and so on, right? So directly take this total and you'll get the answer. So what's the logic here? 0, because for past 1600 years, 0 odd days. 1 for 300 years, 1900. Then why 46? Because up to 1901 to 1946, there are 46 years. 46 years will have at least 1 odd day every year. So 46 and 11 years. So 11 odd days. This calculation we have already understood in the previous example, right? Where we have done in detail calculation. Then this 2 is the helpful part here. Earlier, for the month of August or up to the month of August, we need to calculate for Jan, Feb, March, April, May, June, July. Individually we did the calculation. But now that part is eliminated. Directly take the code for August, which is 2, right, and 15 because the date is 15 here. Now add all these values, we'll get the total number of odd days, and through which we can find out the day of the week. Now do the calculation. See, understand, as I said, wherever we have complete weeks, we can remove that part. For example, 46 is nothing but 6 weeks plus 4 days. 46 can be taken as 42 days plus 4 days. 42 days is equal to 6 complete weeks plus 4. So we can directly take it as 4. Likewise, 11 can be taken as 1 week plus 4 days. And 15 can be taken as 2 weeks plus 1 day. So this way we can simplify our calculation much faster. Now add and find out the total number of odd days. 1 plus 4, 5. 5 plus 4, 9. 9 plus 2, 11. 11 plus 1, 12. So total 12 odd days. But 12 odd days is equivalent to 5 odd days, because 12 odd days can be taken as 1 week plus 5 days. And what does 5 indicate? Friday. So we can say that 15th August 1947 was a Friday. So in fact the same answer, whatever earlier calculation that we had done in detail, that gave us Friday. Here with the help of this column, that is the code for the month, we can get the answer a little faster. Let's take another example to understand the application of this one. Let's consider some other date. For example, 1st of May 1988. Now we have to find out what day of the week it is, right? So no need to worry about that detailed calculation, right? The calculation actually is very simple. 1988 up to 1600 years, 0 odd days. Then 1601 to 1900, 1 odd day plus. Now we are in the 88th year. So forget about the 88th year. First calculate from 1901 to 1987. 1901 to 1987, we have got 87 years. So 87 plus. How many leap years are there in this set of 87 years? In 87 years we'll have 21 leap years, because 87 when we divide by 4 we'll get the quotient as 21. Right, 1904, 1908, so on up to 1984, 21 leap years. And each of these 21 leap years will have one additional odd day, right? So we'll say plus 21, because each leap year has one additional odd day. Now comes the 88th year. Now in the 88th year, we are referring to the month of May. Understand, the year 88 was a leap year, right? 1988 was a leap year. Leap year, and that too, this month is May, which means after February. Are you able to follow? So 1988, the month of February had 29 days, which means one extra day. Here we have considered only 28. So because it is a leap year and the date is after 28th February, we have to consider plus 1, right? So this 1 is an important part here. Be careful about this. Now consider the month of May. Month of May, 5th month, right? May has got how many odd days? What is the code for May? 1. What does this 1 indicate? The total number of odd days for all the previous months. So we'll take that 1 and the first day of the month, that is plus 1 again. Like in the previous case it was 15th August, so we have taken 15. Now it is 1st May, so we have taken 1. So what's the calculation? This 1 indicates the number of odd days for 300 years, 1601 to 1900. 87 is the number of odd days for 87 years, 1901 to 1987. 21 for the number of leap years. What is this one? Since it was a leap year, 88, and the date is after February, we have to consider 1, because Feb had 1 extra day in that year. What is this one? This one is the code for the month here. The code for May is 1, so that 1. And the last one here shows the date, right? 1st of May, so we have to take 1. Now add all these values. See again, 87 can be taken as 3 odd days. 84 plus 3, 84 is equal to 12 weeks. 21 is 0 odd days, right? And remaining all are 1, 1 and 1. So add up 1 plus 3, 4, 4 plus 0, 4, 4 plus 1, 5, plus 1, 6, plus 1, 7. So we have got total 7 odd days. And 7 odd days is equal to 1 week, 1 complete week. 1 complete week means what? 0 odd days. Right? 0 odd days. And what is 0 odd days indicate? 0 odd days indicate Sunday. So we can say 1st May 1988 was a Sunday. So this is how simple is the calculation for finding out the day of the week for any given date, right? Initially it may look to be a little lengthy and complicated, but if you practice a few problems, I'm sure you'll be able to do the calculations much faster, right? All you need to understand is how do you split up the given date, right, in terms of years, months and the days there, right, and the days of the month, right? Just remember that every 100 years we have 5 odd days, 200 years 3 odd days, 300 years 1 odd day, and 400 years 0 odd days. Get the point? And you need to quickly calculate the number of ordinary years and leap years for the additional number of years there, right? For example, here from 1901 to 1987, that calculation, right? And then remember the code of the month. The code of the month you need to learn by heart, right? Simple. Starting from Feb, it is 336, 146, 250 and 35. For January it will not be anything, because if it is the month of Jan, we'll directly take the date of that month. We don't have any previous months there. Okay, and then if you add up everything, you will get the total number of odd days, and with the reference chart of the days there, right, where you have seen 0 odd days is Sunday, 1 odd days is Monday, and so on, you can directly say the day of the week. So 0 odd days, Sunday. That's your answer.